Okay, good day, everyone, and welcome to our grade 12 masterclass. And today, guys, we are going to be doing physical science paper one, which we all know is physics. And I think we can all agree that physics out of physical science is actually the best section. Now, guys, before I start, I just want to say a big thank you for those who have taken time out of your busy days to actually attend our lessons. We greatly appreciate it, and we hope that our past lessons have proved beneficial to you guys in your exams. And just you guys may state in the chat, how are the exams going? You can send a thumbs up or a thumbs down. I saw maths paper one and paper two. There were some interesting questions in there. I didn't see the whole paper, but it looked quite interesting. Hopefully you guys survived that. All right. Didn't look too bad. Okay. But guys, again, we are doing physics paper one. And before we start, I just have to go over some ground rules. For those of you who have attended our lessons, we know what's going on. But for those of you who are here for the first time, I think we have seen that our mics and our cameras have been disabled. Now, guys, we do that for a reason, all right? That's just to prevent any distractions from occurring, all right? We don't want any background noise to interfere with the lessons. Another thing, guys, is if you have any questions, you may feel more than free to post in the chat. All right. That's why we have not disabled the chat. Okay. Now, on top of that, guys, please can everyone state their name, their school, as well as the number of people who is watching this lesson at your device. So if it's just you, you put your name, your school, and the number one. If you are presenting, if you are a teacher and presenting this to an entire class, you put your name, your school, and the number of people in that class, including you. All right. But guys, without further ado, we can get started. Guys, and one last thing before I even get started, please understand that this is a learning environment, all right? I did ask you guys to go through this paper beforehand, all right? So if I ask you to answer, please try and answer, all right? Try and engage and interact. If you don't know, don't be shy to ask, all right? Please, guys, that's part of learning to ask questions, to attempt things. Even if you get it wrong, you will still learn something out of it, all right? So without any further ado, we can get started. So guys, remember we are doing maths paper one, maths paper one, physical science paper one, and that is physics. All right. And before you even start writing, always look at the instructions and information that is given. All right. Because sometimes if you do not follow those instructions properly, even if your answer is correct, you will lose marks. Okay. So here, guys, it just says that write your name in the appropriate space in the answer book. Okay, there's 10 questions. You may use a non-programmable calculator, use the appropriate mathematical instruments. Maybe you need a protractor or something, and rulers for drawing graphs. Use the attached data sheets. Okay, I think the most important one is this one. Number 10, round off your final numerical answers to a minimum of 2 decimal places. All right. So guys, please, your answer must at least be 2 decimal places. All right. However, because it says minimum, if your answer is 3 decimal places, you can keep it to 3 decimal places. All right. So, but just remember 2 decimal places or more. But if you just round off to the nearest whole number, you might lose marks. And then finally, number 11 says give brief motivations, discussions. So, guys, when they ask explain why, don't write out a full essay. Just give the important points and then move on to the next question. All right. You don't, this is not English paper one, it's physical sciences paper one. And then finally, and the most important one out of all these instructions, write neatly and legibly. If you do not write neatly, especially for your final exams, remember your teachers are the people that are going to mark your exams are going to be marking hundreds of exams. And the term that they're going to become is called gatvol. Okay, they're going to get so exhausted by the time they get to your paper. If they cannot make out what you are writing, even if you have written the correct thing, they'll just go and then move on. So write neatly if you want to get good marks. Okay. Moving on. So let's start with question one. And guys, we all know question one is our multiple choice questions. All right. And I personally enjoy the multiple choice section because unlike all the other questions, multiple choice tests whether you actually understand the work. All right. In every other question, you can just write down an equation, substitute, get an answer. You are going to get some marks. But with multiple choice, you actually need to have a good understanding of physics paper one in order to be able to answer those questions and to get good marks in your multiple choice. All right. And for most people, I will always advise leave your multiple choice till the last. Okay. Answer all the other questions and then answer your multiple choice last so you can have enough time to answer everything else. Okay, so let's get started. 1.1 asks, a wooden block is pulled up a rough, inclined surface using a rope. The wooden block moves at a constant velocity. Now, guys, that's a very important word, okay? Constant velocity. What does it mean if an object's moving at constant velocity? Number one, my acceleration is 0, and the sum of my forces, or my net force, is 0. All right? So, this means that, so is it A? There are no forces acting on the block. No. All right. If your net force is 0, it means that all the forces going in one direction is the same as all the forces in the opposite. It doesn't mean that there are no forces acting on the block. All right. So it cannot be A. All right. B, there are no vertical forces acting on the block. Well, technically there are. There can be a weight force and a normal force. All right. And like I said, it's on a rough horizontal surface. So there is. But again, these forces are going to cancel out. All right. So it cannot be B. Only gravitational force acts on the block? No. Like I said, the surface is rough and horizontal, so it means that there's going to be friction, so it cannot be C. So therefore, it has to be D. The vector sum of all the forces on the block is equal to 0. All right? And you see how you answer, guys. You answer by a process of elimination. Okay. Next question, 1.2 states, the mass of an object on Earth is represented by x over g. Which one of the following represents the mass of an object on a planet that has twice the mass of Earth and half the radius of Earth? So what was your answer for 1.2? Can you guys state that in the chat for me, please? You can state, okay, I see A, B. What else? Who else answered? I see an answer for C. Okay, interesting. C, I get a lot of C's. One, two, a few more B's. All right. So the correct answer, ding, 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 is B. Now, why is that? Let's read carefully. They said the mass, and they even put it in all caps, is represented by da da da. And they also said which one of the following represents the mass of the object. Guys, an important note, if in case you didn't know, mass is not the same as weight, all right? And the reason for that is your mass always remains constant. No matter where you are in the universe, I can be standing on Earth, I can be in space, I can be standing on the surface of a black hole. My mass will be the same. The thing that changes is your weight. Because remember, mass is simply m, and weight is mg, all right? So if they asked what would the weight of the object be, then you will have to now figure it out. But guys, because they are asking what is the mass of the object, your mass remains constant, all right? So they try to trick you there, okay? Next question, okay, I just need to read it up. Can't see, okay, yeah, I can see it. Ball A of mass m is projected vertically upwards from the ground with an initial velocity of v. Ball A rises to a maximum height, that's an important word over there, maximum height h above the ground. Okay, then they say ball B of mass 1 over 2m is now projected vertically upwards with an initial velocity of 2v. Okay, ignore the effects of air friction. In terms of h, what does the maximum height or what maximum height does ball B rise above the ground? So they want to know what is the maximum height of ball B in terms of ball A. Okay, so what was your answer for there, guys? This was quite a tricky one. So what do you guys think your answer for that is? D. Okay, a lot of D's. Okay, I see one B, a few C's. Okay, so I'm going to go through the answer. So let's picture what's happening. Over here, I have ball A and I throw it to a certain maximum height of h. Now, what's the initial velocity of ball A? It's simply v. What's the final velocity at the maximum height? Remember, when you reach your maximum height, your final velocity is always 0. Alrighty. So, what I'm going to first do is I want to figure out, okay, how do I represent the velocity of ball A in terms of its height? So I'm going to show you how you can do that. So I'm going to look at ball A, and I'm going to say, and there's multiple equations you can use. I found that this one was the easiest. I'll say that the final velocity squared is my initial velocity squared plus 2a delta x. And I'm taking up as positive because the ball is projected upward. It just makes it a bit simple, okay? Now, remember your final velocity 0 is equal. Now, the initial velocity is just v. So it's v. Now, because I have taken up as positive, my acceleration, which is our gravitational constant 9.8, is negative. So I'm going to say minus 2g. And our displacement, well, it's just the maximum height h. And I'm going to solve for v. So you get that. Oh, sorry, this is v squared. So I get that v squared is 2gh. And therefore, v is simply the square root of 2 times g times h. So that is the velocity at which ball A was projected upwards. So if I know the height of the ball reaches, I can figure out its initial velocity. Now I'm going to focus on ball B, all right? Because that's actually what we need to work on. I'm going to change the color just so it's a little bit easier to see. So, oops, where's my pen? Oh, there. So I'm going to say that ball B, all right? And I'm going to use the same equation. Now remember, this is ball B, and the initial velocity is simply 2 times v. All right, that's what they've told us. Again, it reaches a maximum height, and I'm just going to call this hb. And I know that at that maximum height, my final velocity is still 0. All right, now guys, you see, I'm actually not even worried about the mass, okay? In projectile motion, if you project something upwards, you don't really have to worry about the mass, okay? So again, I'm going to use that same equation. Vf squared is equal to vi squared plus 2a delta x. And I'm going to take up again as positive. So therefore, 0 is equal to 2v squared. All right. If you square that, you get simply, where's my pen? You get 4v squared minus 2 times g times the height of b. And I want to figure out this value over here. So what I do, guys, I simply solve for that. I take this 4v squared other side, I get negative 4v squared is equal to negative 2g times h of b. And if you solve for this, you get that therefore the height of b is simply 2v squared over g. Alrighty. What can I do now? Remember, I know what v is. This is what I figured out first. So again, I therefore get that the height of b is equal to 2 times. Now I simply put this in. So it's the square root of 2 times g times h squared over g. All right. If you square this, the square roots just cancel and you get 2 times 2gh over g. Now look, the g's are going to cancel, and therefore the height of b is simply 4 times h. So the answer is D. So for those of you who got D, well done. For those of you who didn't, I hope you guys understand. If you are still struggling to understand, don't worry, this video is recorded. You will get the recordings after this lesson, and you can just maybe replay the video, try and answer the question again yourself to figure out the answer. Okay? Moving on. 1.4 says, an object with a mass of m moving at velocity v collides head-on with an object of mass 2m moving in the opposite direction at the velocity v. Immediately after the collision, the smaller mass moves at a velocity v in the opposite direction, and the larger mass is brought to rest. Ignore the effects of friction. Refer to the diagram below. So this is what they've showed us, guys. And then they say, which one of the following regarding momentum and kinetic energy of the system is correct? So, what did you guys get for this one? You can post your answers. Well, this is 1.4. Okay, I got C's and D's. Okay, so now we're going to see how we can answer this. The first thing is, I'm going to first pay attention to momentum. What did they tell me that was very important? They first said that there was a collision, obviously, and then they say ignore the effects of air friction or of friction. So I know that this is an isolated system, right? There's no external forces. So in an isolated system, what happens to the momentum? Momentum is conserved. So I know it cannot be B and it cannot be D. So the answer is either between A and C. So now I have my momentum checked. Let's look at the kinetic energy now. Remember, we need to focus on is the kinetic energy conserved or not conserved? All right. So this is how we can do that. Let's look at the sum of our kinetic energy before the hit. So here, all right. And I'm just going to call this block M, object A, and block 2M, object B. All right. So the sum of our initial kinetic energy is simply the kinetic energy of block A plus the kinetic energy of block B. All right. Then this becomes a half times M times V squared plus 1 over 2 times 2M times V squared. All right. Now look over here, guys. By this half times 2, they will cancel. And simply, if you do the math, you get that the initial kinetic energy is simply, this becomes a half mv squared plus mv squared, which is 3 over 2 mv squared. So that is before the collision. Now let's look at what happens after the collision. So the sum of my kinetic energy final or after the collision is simply the kinetic energy of A plus the kinetic energy of B after they have collided. All right, that's very important. Now here's a key thing. The final velocity of F is 0. So I can ignore, or sorry, the final velocity of B, remember this is A and B, is 0. So I can actually ignore the kinetic energy of A and just look at the kinetic energy, or sorry, I can ignore the kinetic energy of B and just focus on the kinetic energy of A. So this is simply 1 over 2 times M times V squared. All right? Therefore, your final kinetic energy is this, 1 over 2 mv squared. Now, are they the same? No. So the final kinetic energy is not the same as the sum of my initial kinetic energy. So I know that my kinetic energy is not conserved. So therefore, it cannot be A. So the answer is C. And guys, this is important how you should answer your multiple choice. You should do this process of elimination. It makes it so much easier. Next question. All right. The graph below represents a constant form F doing, I can't see it now, just type it out. Let me just go check quickly. Yeah. Constant force F acting on an object over displacement X. The force F and displacement are in the same direction. All right. So which one of the following statements can be deduced from the graph? What was your answer for this? Okay, 1.5. Okay, so let's read what it says. Which one of the statements can be deduced? The gradient of the graph represents the work done by the force. All right, so I know that work is equal to simply force times displacement or distance. All right, what's the gradient of this graph? Well, remember gradient is y over x. So this is my y value, which is my force, divided by my displacement, which is x. All right. So this is simply my force over my displacement d. Now, this is the equation for work. This is the gradient. You can see that they don't match, so it cannot be A. Cannot be A. The gradient of the graph represents the change in kinetic energy of the object. Now let's see that. Well, we know that work is equal to your change in kinetic energy, and I can already see that this gradient does not represent work, so therefore it cannot be the kinetic energy. So as over here, the area under the graph represents the net work done by the force. All right, so remember area is simply your x-axis multiplied by your y-axis. So this becomes force times displacement, all right? Okay, now work is equal to force times displacement, and the area is force times displacement. So maybe it's that, all right? And then D states the area under the graph represents the power dissipated. Guys, power is not represented like that. Power is written as force times velocity, okay, not displacement. So therefore, it cannot be D. So my answer is C. Okay, well done for those of you who got C. Here it goes. A car travels for 1.6. A car travels at constant velocity along a horizontal road. A constant frictional force acts on the car during its motion. Which one of the following statements is true about the power dissipated by the engine of the car during the motion is correct? So which one of the following statements is correct? The power is A, 0. B, the power increases. D, it decreases. Or C, it decreases, or D, it remains constant. So the answer is, yeah, I see a lot of D. So sometimes when answering these questions, your best friend is your formula sheet, all right? And I want to find a formula that relates power as well as velocity, because what did they tell me? They said my velocity is constant. And I found this one. Power is simply the force times my velocity. Now, guys, my velocity is constant, and I can see that power is proportional to velocity. So the velocity of an object is going to be constant. The power is also going to be constant, so therefore it is D, all right? Quite a simple one, okay? 1.7 says, light reaching the Earth from a galaxy moving away is shifted towards, what answer was that, guys? Remember, if this is our galaxy, this is our spiral galaxy. All right, beautiful. This is an observer on Earth, right? There's his eyeball. The galaxy is moving away. So what's going to happen to the light? The light emitted is going to be stretched out. It's going to be moving that way and that way. So therefore, my wavelength is going to increase, right? My frequency is going to decrease and so on. And what are the options? Greater velocity, higher velocity, longer wavelength, shorter wavelength. I think we all know the answer. That's C. Okay, remember, if light moves away, the light gets stretched out and your wavelength increases. Okay. Two charges, one of positive nanocoulombs, the other one of negative 2 nanocoulombs and positive 2 nanocoulombs, are located on a straight line S and T. On a straight line, sorry. S and T are 2 points on the line, 2 points that lie on the same straight line as shown below. Which one of the following correctly represents the direction of the resultant electric fields at S and T? So guys, remember, you first focus at one column. You don't now look at the whole thing. Let's just pay attention at each column. I'm going to change the color to make it a darker color. So I'm going to focus over here first, all right? The direction of the resultant electric field at point S. So point S is over here. Remember, you take that as a positive, right? You assume that that's a positive point. Now, what's going to happen? Well, because this is positive, this is also a positive. That's a negative. So what's going to happen? This positive charge is going to push S that way. On top of that, this negative charge is going to attract S that way. So I know that my F net is to the right. All right. So I immediately know I need to select the options that have right in it. So I can cross out this one. I can cross out this one. So it's either A or C. Now let's focus on this one and this one. Now let's focus on the direction of the resultant at point T. So I'm just going to erase all of this. Okay. And I get out my pen. Remember, you assume that point T is also a positive. Now, what's going to happen? Point S is going to attract it that way. Oh, sorry, this negative 2 nanocoulombs is going to attract it that way. And this positive 2 is going to push it away. And now here's the thing. Because point T is very, very far away from that positive charge, that force of repulsion is going to be very small compared to that force of attraction, all right? So this one is going to be a lot greater than that force of repulsion. It's going to look something like that. So therefore, I know that my net force or my net electric field, oops, that's supposed to be E, is going to be to the left. All right. So therefore, my answer for 1.8 is A. All right. So it cannot be C. Okay, perfect. So always remember in your definitions, they say the direction of an electric field is the direction that a positive test charge will move if placed in that field. So that little point that you put in there, you always assume to be positive. All right. That's how you answer it. So moving on, 1.9. It says the diagram below shows four identical bulbs, M, N, P, and Q, connected to a battery. The power dissipated in bulb M is 60 watts. The resistance of the connecting wires and the battery may be ignored, okay? Then it says the power dissipated in bulb Q is, and what's the answer for that? Remember, guys, let's look over here. Current is going to come out the battery, and then it's going to flow, and it has an option between flowing through this branch, I'm going to call it 1, and this branch 2. All right, so you can either go into branch 1 or branch 2. Now remember, current is like water. Water always tries to flow through the path of least resistance. Which path has the least resistance? The one that has no resistance in it. All right, this one over here. So therefore, this is something we call a short circuit. All right, we've made a short circuit. So all my current is going to go through this branch because there is no resistance. So therefore, yeah, there's going to be no current going through that bulb. So therefore, the power dissipated is simply going to be 0. So the answer is A. Okay. Final one. The diagram below represents 3 energy levels, X, Y, and Z, in an atom. The energy difference between levels Y and Z is twice the energy difference between levels X and Y. So Y and Z is simply 2 times X and Y. All right, so I'm just going to rewrite it. So let's say, okay, let me just rewrite it and change color. Let's say the energy here, let's just call it K. This means that the energy difference here will be 2K, okay? That's it. Then it says, if the wavelength of the photon emitted as a result of transition P from level X to level Y, so from this over here, as this electron goes from this orbital to this orbital, it's going to emit some sort of a photon, and it's going to have a wavelength of lambda. Then it says that then the wavelength of the photon emitted from transition Q from X to Z is going to be what? Now, guys, let's look at the energy being emitted. The energy emitted over here is simply going to be equal to K, as this is for the energy of P. So as my electron goes from X to Y, it's going to emit an energy of K. All right, I've just written it like that just to make it a bit simple. Now, what will the energy transition be for Q? It's simply going to be this plus that, right? You simply add up all that energy levels and you're going to get 3K, all right? So that's the amount. So the energy being released from the photon for Q is 3 times that of the energy being released from the photon of P, all right? Now here's the thing. We know that energy is equal to H times F. So therefore, if you expand F, you get that energy is simply Hc over lambda. All right. Now, what can I see over here? I know that energy is proportional to, or inversely proportional, sorry, to lambda. So that means if my energy is 3 times greater, my wavelength is going to be 3 times smaller. All right. So therefore, the answer is D. Okay, did you guys understand that one? So if my energy is 3 times greater, because of this inverse relationship, my wavelength is going to be 3 times smaller. Okay? And that was multiple choice. Now, guys, are we still awake? Are we still alive? Still, we have gone through the most difficult part of our paper. Now we can get to the actual calculations where you can get most of your marks. Perfect. All right. So if you remember, if you are struggling, if you don't understand, I will try my best to answer your questions. All right. Remember, guys, we will share this video at the end of the lessons. So if you have missed something or if you still don't understand, you will get the video and then you can just watch it. Okay. The answer for 1.10 was D. Okay. 1 over 3 lambda. Thank you, guys. Okay. Without any further ado, let's get to question 2. Oh, that rhymed. Anyways. It says over here, block M1 of mass 8 kilogram placed at point X is connected to block M2 by a light inextensible string passing over a frictionless pulley. At this level, guys, you don't have to worry about the pulley getting involved, but at undergrad university, you actually do have to consider that. Okay? Block M1 is on a plane inclined at an angle of 30 degrees to the horizontal and experiences a frictional force between X and Y. Block M2 has an unknown mass and moves vertically downwards as shown below. Block M1 is released at point X and moves at a constant velocity. Oh, that's a very important term. Constant velocity to point Y. The coefficient of kinetic friction acting on the 8 kilogram block is 0.2. Okay. 2.1.1 says, state Newton's first law of motion in words, guys. That is your definition. There is the definition below according to the exam guidelines. Please, guys, make sure you know your definitions. Your examiners are very finicky when marking your definitions. If you are missing 1 or 2 little important words or phrases, you will not get the full 2 marks. And losing 2 marks for a definition is very silly to lose, okay? Please always understand that. All right. 2.1.2 states, draw a free body diagram indicating all the forces acting on M1. So guys, this is M1. So what you first do is you start with a nice big fat dot, and let's focus on the forces. The first force I obviously know is going to be a weight going straight down. That's the weight force. Another clue, guys, is let's look at the marks. There are 4 marks, which means 4 forces needs to be named. On top of that, because the block is moving from X to Y, I know that there's going to be a friction going down the slope. So there's a frictional force. On top of that, there is tension. There's a rope pulling this thing upwards like that, right? And that's our tension force. Now, what's the final force I'm missing, guys? That is my normal. Okay, that's always perpendicular to the surface. And it's basically the result of that box being in contact with the surface. And those are my 4 forces. So I know I'm going to get 4 marks. 4 easy marks to get. Alrighty. So 2.1.3 says, calculate the magnitude of the frictional force acting on M1. All right, so on the block. So I know that friction is equal to the coefficient times the normal. So let's look over here. All right, this is my frictional force. This is my tension, friction. This is my normal. And this is my weight. Now remember, what can you do with weight? You can draw it into its components. So this is my parallel component, W parallel. This is W. And this is my perpendicular component, W perpendicular. All right. And in this case, when you are dealing with a box on an incline, your normal is the same as your perpendicular component. So therefore, my frictional force is my it's that times my perpendicular component. You expand everything, and this becomes mg times the cosine of theta. And all I do now is I substitute. So this becomes 0.2, which is my coefficient, times the mass, which is 8, times 9.8 times the cosine of 30. You type that all onto your calculator and you get that the frictional force is simply 13.58 newtons. And there we go. Simple, easy answers. Okay. Please resend the paper on the group. Yeah. So guys, the paper has been shared on the WhatsApp group, so don't worry. Someone says go back to the drawing again. All right, so this is a drawing, guys. And remember, you cannot draw components anymore. They will deduct marks. You have to draw the proper forces and not its components anymore. Okay. Okay, that's our frictional force. Remember, guys, you will be getting the recording very soon. All right. 2.1.4 states, calculate the mass of M2. So, guys, what answer did you guys get for 2.1.4? What was the mass of M2? I get 5.39. Okay, who else got the answer? Let's see, I only see one answer. You guys remember, don't be shy to post your answers. 5.39. Okay, okay. Might be correct. Okay, so let's figure it out. So remember, when dealing with this, you always know simultaneous equations. So I'm first going to focus on block M1. So I'm going to say block M1. Bam. Now I know that the sum of my forces is equal to 0. Why? Because they told me this thing was moving at a constant velocity. So let's just draw it out again. So this is block M1, tension, friction, and I'm also going to include this component. So this is friction, my W parallel, W perpendicular, and the normal. And then this is tension. All right? Now, when the sum of your forces is equal to 0, it simply means that all the forces going in one direction is the same as all the forces going in the opposite direction. So therefore, tension is equal to friction plus my W parallel, which is mg times the sine of theta. Okay? So what I'm going to do is I'm going to figure out what my tension is, what the tension on the rope is. So this becomes simply 13.58 plus this, which is just 8 times 9.8 times the sine of 30, which is simply a half, if you guys remember your special angles. And therefore, tension is equal to 52.78 newtons. Bam. Now what I can do is I'm going to just change colors. Yeah. I'm now going to focus on block M2. So this one. All right. So block M2. And remember, guys, when doing this, always draw force diagrams. Your force diagrams are your best friend. So for block M2, it's simply going to be the tension on the rope and the weight. All right, the weight. So therefore, again, the sum of my forces is still equal to 0. So therefore, the tension of the block is equal to the weight, which is mg. All right. So we know the tension we already got in the previous one was 52.78 is equal to the mass of our block, m2, times 9,8. You type this all onto your calculator, and therefore you get that m2 is equal to 5.39 kilograms. And there we go. All right. Very easy 5 marks to do. Okay. I hope you guys understand. Moving on. There. Okay. So do we all get that answer, guys? Let's just see. What do you mean? Someone said the sign for friction and tension is the same. What do you mean by that? Remember, friction is an F, and then tension is a T. Okay. If you guys cannot see the screen, just try and exit the chat and rejoin. But I assume all of us can see the screen. You can see a thumbs up or a thumbs down. If you can see the screen, send a thumbs up. If you can't see this screen, just send or just state you can't see it. Okay. And guys, always remember, W parallel is mg sine of theta. And then W perpendicular is mg times the cosine of theta. Okay. Just write that down and remember it. Okay. It's very important. Okay. So remember, friction always acts in the opposite direction. All right. So friction was acting in this direction. Where's my pen now? So friction was acting in this direction, as you can see over here, as well as my component. They were acting in the opposite directions. But because my net force was 0, it simply meant that all the forces going up were equal to all the forces going down. All right. So my tension was equal to the sum of my friction and my a parallel component of weight. I hope that answered your question. Okay. All right. Block A, the 8 kg block continues to move past Y. We're going to see because my question is a bit cut out over here. So it says that the 8 kg block continues to move past Y and up the incline. How will the magnitude of its acceleration be affected? Increases, decreases, or does it remain the same? And give a reason for your answer. So guys, you can answer that question, but answer it with a reason. Very good. Yes, guys, it is increases. All right. So you write increases. Now, why? Remember, by removing frictions, there is a net force. So there is a net force up the slope. All right. Because now the forces are no longer canceling out. Therefore, an acceleration is up the slope, and acceleration also increases. All right. Remember, if you take away a force, it's gonna cause a net force, and therefore it's gonna cause an acceleration. So therefore, it increases. Now, guys, please do not write anything else other than increases. If you say it gets larger or it goes up, you will not get the mark, okay? Because you are not following an instruction. They said only write down increase, decrease, or remains the same. Please, guys, remember that. Okay. 2.2 states, let me just get it out quickly. It states, on a particular day, the distance between the surface of Earth and the surface of Mars was 4.5 times 10 to the power of 9 meters. Mars has a mass of that value over there and a diameter of 6,779 kilometers. 2.1.1 states, state Newton's law of universal gravitation. That's your definition, guys. I'm not going to go into that. Just remember, always try and know it off by heart, and this is available in your exam guidelines. 2.2.2 states, calculate the magnitude of the gravitational force Earth exerts on Mars. So I know from the get-go, my gravitational force is my constant times the mass of Earth multiplied by the mass of Mars divided by the distance between them squared. All right. Now, here's the thing. Let me just change it to a different color. Let's just make it green. This has been given to me. All right. This is at the back of your formula sheet. The mass of Mars is given to you there. It's been given to you over there. The only thing we need to figure out is the distance between them, right? So I'm going to write it over here. I'm going to change it back to blue. I'm going to write that the distance between them is that distance that they've told us plus the radius of Earth plus the radius of Mars. Now, why do I say that? Let's look at it. Right? This is Earth, and this is Mars over here. All right? And they said that the distance between their surfaces was that value that they've told us over there, 4.5 times 10 to the power of 9. But remember, guys, FG has to take into consideration the distance between their centers. So in order to get to the center, you have to include their radii as well. All right? So that's why I said the complete distance between them is that value that they've told us, plus the radius of Earth and the radius of Mars. Okay? Does that make sense? Do we all understand that part? Okay? So therefore, I'm just going to write this equation again. A of G is G times the mass of Earth multiplied by the mass of Mars divided by the distance between them squared. So this just becomes 6.67 times 10 to the power of negative 11. The mass of Earth is 5.98 times 10 to the power of 24. The mass of Mars was 6.417 times 10 to the power of 23. Now let's divide it by the distance between them squared. All right, so the first distance they gave us was that 4.5 times 10 to the power of 9. So it's 4.5 times 10 to the power of 9 plus All right, now I'm going to add it to the radius of Earth, which is 6.38 times 10 to the power of 6 plus the radius of Mars. Now look what they've given us. They've given us the diameter of Mars. All right, I need to know the radius. So how do you find the radius? You simply take the diameter and divide it by 2. But now here's another issue, okay? That value needs to be in meters. So I need to take that 6,700 kilometers divided by 2 and multiply it by 1,000 to get to my answer in meters, to figure out what the radius is in meters. So this is simply, what's the value over here? 6779 over 2 multiplied by 1,000. All right, and remember, you square everything. Make sure everything is in a bracket, guys, and then you square that bracket. And you type all of this on your calculator, and you get that your gravitational force is about 1.26 times 10 to the power of 19 newtons. All right, so that's the force between the two planets, okay? Do we all understand this question, okay? Wasn't a very difficult question. You just had to realize this part over here. The distance between their centers was that distance that you gave that they gave us, plus the radius of Earth and the radius of Mars. Okay? You type it all onto your calculator and you get this value over here. Okay, guys? So are we still awake? Are we still alive? Do we still understand all of this? All right? I hope so. Perfect, perfect, perfect. All right, let's get going. Question 3 it is. Now, question 3 is always our projectile motion, okay? So, it says learners in a grade 12 class launched a rocket from rest vertically upwards from the ground. Assume the rocket experiences a constant acceleration for 1.8 seconds to reach a maximum velocity of 29.7 meters per second, at which point it runs out of fuel. Ignore the effects of air resistance. The sketch below, not drawn to scale, represents the position of the rocket relative to the ground from the moment it was launched until it crashes back on the ground. Take upwards as positive. All right. So basically, guys, we have a rocket. All right, and we get it to this certain height over here, and at this height, it runs out of fuel. Okay, just remember that. So, hopefully I've stated everything. Perfect. Then it says 3.1.1, oh, sorry, 3.1 asks, during which time intervals was the rocket in free fall? So guys, what was the answer for that question? Remember, I'm just change my color. Remember, this was our rocket. And then it got to this height over here where there was no more fuel, but it had a velocity of 29.7 meters per second. So for which interval? Perfect, guys. Remember, it's between this point over here at 1.8 seconds and the time it took for it to hit the ground. So therefore, it's between 1.8 seconds and time t2. All right. This says calculate the acceleration the rocket experiences from 0 seconds to 1.8 seconds. And guys, we can use our equations of motion. Remember, it doesn't just apply to projectile motion, it applies to motion in general. So I'll say that the velocity of my rocket, or the final velocity, is the initial velocity plus a delta t. Remember, we are taking up as positive. So what's my final velocity? It was 29.7 meters. Okay, is equal to my initial one, which was 0, plus a times 1.8. All right. And guys, you solve for this and you get that your acceleration between 0 and 1.8 seconds was 16.5 meters per second squared. Okay, remember guys, this is when the fuel was burning, pushing that rocket upwards, okay? It was not in free fall at that moment in time. Okay, I have a question, says, please explain that, please. Do you mind being a little bit more specific? I do not know what that is, so just try and be 3.1. Remember, between 0 and 1.8 seconds, it was not in free fall. There was an engine busy accelerating that rocket up to a certain height. Once it got to that height, there was no more fuel. So at H1 beyond, there was no more fuel. And after that, the rocket was just in free fall. So it had some momentum, it carried it up, but eventually it stopped and then it fell back down. So between 1.8 seconds and time T2, that's when the rocket was actually under free fall. Okay, I hope that answered your question. Yes, the memo is available. Just look it up at testpapers.com or just stay in the lesson. Okay. Anyways, moving on. 3.3 states, calculate the maximum height H2 above the ground reached by the rocket as indicated on the graph. So guys, what was the maximum height of our rocket? Who can tell me? Okay, okay. Wait, it's my water. Okay, perfect. Yes, so the maximum height is at H2, but what was the value for that? Okay, so let's figure it out. So there are two heights. There's this H1 and this H2, all right? So what I'm going to first figure out is how high was this rocket at this point over here, okay? So I'm going to first look at H1, and I'm going to use this equation, delta y is equal to my initial velocity times delta t plus 1 over 2a delta t squared. Remember, I'm still taking up as positive. Now, here's the thing. They specified to us that my initial velocity was 0. So I can ignore this whole section because if this is 0, everything in this little part will be 0. So therefore, delta y is equal to a half times a times t squared. All right? All I need to do is I need to substitute. This becomes 1 over 2 times my acceleration, which was 16.5, times the time, which was 1.8 squared. And therefore, the height at H1 is simply equal to 26.73 meters. But guys, I'm not done yet. That's the height that it reached when the fuel ran out. Okay, so this is when there was no more fuel left. Okay, this is our little rocket. I want to know, okay, at this point, we know it was traveling at 29 point something meters per second, right? How high did it go beyond this point? So what was the maximum height reached after the fuel cut off? Okay, so I'm going to say max height after fuel, oops, ran out. Okay, I'm just going to call it that. So again, let's figure that out. Now, there's a lot of stuff you can do, but I'm going to say that, I'm going to use this one. I'm going to say that my VF squared is equal to my initial velocity squared plus 2a delta y. All right, and my delta y is the maximum height reached after the fuel ran out. So it's basically this part over here. So again, remember at your maximum height, your final velocity is 0. So therefore, 0 is equal to 29.7 squared minus 2 times 9,8. Remember, acceleration is downward, so I'm going to make that negative, and that is delta y. All right. So therefore, if you type this all out, you basically solve for delta y, and you get that delta y is equal to 45 meters. All right. I just skipped 1 or 2 steps. Remember, it's basic algebra. So therefore, after the fuel cut off, let me just neaten this up for you guys. Our rocket went, so after the fuel cut off, the rocket still went another 45 meters up. So this height over here is 45 meters. So what's the total height? So therefore, I'll say that H2, which is the maximum height above the ground, is simply this 45 plus 26.73. And therefore, the height at H2, or the maximum height, is 71.74 meters. All right. I hope that makes sense to us. All right. Remember, you first calculate, okay, how high did the rocket reach before the fuel ran out? After the fuel ran out, how high did it still travel? And then you simply add those two values together and you get your final answer of about 71, 72 meters. All right, just under 72 meters. So that was quite powerful fuel that they've used. Okay. 3.4 says calculate how long the rocket was in free fall and hence the value of T2. So what they want to basically know is what was this time, or how long was the rocket in free fall for this amount of time? So guys, what did you get for that value over there? Okay. So someone said, why is 9.8 not negative? But we know it's always going down. It is negative. All right. If you take up as positive, anything going downwards, any vector going down is a negative. All right. So I did take it as negative. That's why I said it is minus 2 times 9.8. Okay. So yes, I get a lot of answers for 8.66. So let's figure out the answer. Okay. So what I'm first going to figure out is, because they want to know what is the value of T2. I first want to figure out, okay, what is the value of T1? Okay, so let's figure this out. Firstly, I know that T1 is simply the time it takes for this height. So I'm going to say it's delta T. So the time it takes for it to go from H1 to H2 plus 1.8 seconds. That's the value for T1. It's this time plus the time it took for it to reach the maximum height. So all I need to now do is I need to calculate how long did it take me to reach that height. Okay, there's many equations you can use. I'm going to use this one. I'm going to say that my final velocity is my initial velocity plus a delta t. Okay, and again, you are taking up as positive. What's your final velocity at your maximum height? We should all know this by now. It's 0. So 0 is equal to my initial velocity is this point over here when the fuel cut out. Okay, this is when there was no more fuel left in my rocket. That was 29.7 meters per second plus negative 9.8, because remember, acceleration is always downwards, delta t. Okay, so you get that negative 29.7 is equal to negative 9.8 delta t. So therefore, delta t is 3.03 seconds. Okay, so what does that mean? That means the time it took for me to go from H1 to H2 was about 3 seconds. So the total time for T1 is simply 3.03 plus 1.8, and therefore T1 is equal to 4.83 seconds. So that's the value of T1. Okay, I have that. Now I need to figure out T2. I'm not done with this question yet. So again, many different ways you could have done this. I'm going to use this one. I'm going to use, okay, I know that at this point over here, at T1, my velocity was 0. All right. I also know that the total height over here was about 71.74 meters. I can now use those values and try and figure out how long did it take for my little rocket to go from its maximum height back down to the ground. So I'm going to say that 42, my change in my delta y is simply vi delta t plus 1 over 2a delta t squared. And now, guys, here's the thing. They said you must take up as positive, so I'm going to keep up as positive. What's the value of my displacement? Remember, you are going down now. So your displacement is going to be down. You've taken up as positive, so that becomes negative 71.74 is equal to, again, remember, we are starting at the top. What was your velocity at that maximum height? It was 0. So that is equal to 0 minus 1 over 2 times 9.8 times delta t squared. All right, you solve for this and you get that delta t squared is equal to 14.64. So therefore, delta t is equal to 3.82 8.26 seconds. Okay. Now that is the time it took for this thing to go from the maximum height back to the ground. So therefore, the value of T2 is simply T1 plus this delta T, which is 3.826. So this becomes 4.833 plus 3,826. And therefore, the time for T2, as all of you guys have gotten, was 8.66 seconds. Okay, you can't see the rest, but it's over there. Okay, do we all understand? Do we all understand? I see my laptop is almost flat, so I'm just going to plug it into charge. There we go. Okay, just make sure the laptop is plugged in. There we go. Perfect. There we go. All right, next question. Okay. Now this states, sketch a velocity time graph in your answer book for the motion of the rocket from the moment it is fired until it hits the ground. Clearly indicate the following on your graph. Number one, you must indicate the velocity of the rocket when the fuel runs out and the time value of T2 when the rocket crashes on the ground. Okay, so what is that time? So how long did it take for it to hit the ground again? So let's break it down into sections. I'm first going to look at the velocity when the rocket's fuel was burning. So can someone tell me what was happening to my velocity when the rocket's fuel was burning? Was it increasing or was it decreasing? Who can tell me that? The velocity of your rocket as that fuel was burning, was your velocity increasing or decreasing? Very good. Your velocity is increasing, all right? It has acceleration, so the velocity is increasing. So I know that for the first few seconds, so for about 1,8 seconds, oops, I forgot to label my axis. This is velocity, this is time in seconds, this is velocity in meters per second, all right? So for the first 1.8 seconds, my rocket was accelerating, right? The speed was increasing until it got to about this height over here, where the speed was 29.7 meters per second. What happened after that fuel ran out? Remember, that fuel ran out, the rocket was still moving up. But what happened to its velocity? Did the velocity increase or decrease? I'm going to change colors now. Who can tell me what happened to the rocket what happened to its velocity after the fuel ran out? Very good. The rocket started slowing down. So my speed started slowing down, oops, until it got here to its maximum height. At the maximum height, remember, the velocity is 0. And then what happened? It started increasing all the way in the opposite direction until it crashed on the ground. Okay? So over here, what's the value over here? They said indicate time T2. We knew it took about 8.66 seconds. Now, did we follow our instructions? One of them said you have to clearly indicate the velocity of the rocket when the fuel runs out. We've done that. Indicate the value of time T2. We've done that, right? This was T2. All right, and this over here was T1. Okay, so we've indicated what they've asked us. So now we are done. All right. Yes, so at this point over here, this is when the rocket slowed down, it reached its maximum height. Any point afterwards was when it was falling in the opposite direction. Remember, I've taken up as positive. Okay, so there. Now, guys, are we still awake? Are we still alive? Is there any questions you would like to ask me? I'm just going to give you guys 1 minute to ask any questions before we move on. So if you guys need a water break or something, you can take it. But you have 1 minute to ask any questions before I move on to the next question. Yeah, okay. So do you get a mark for the graph? Yes, you do. What's very important is this maximum height over here must not be the same. Remember, remember, basically, this is when it was in free fall, and it fell beyond that point here. All right, your graph looks something like this. Okay, so this was when, so this point to that point is this point to this point, and this point to that point is this point to that point. All right. Okay, remember that. And the velocity here just before it reached the ground is greater than the velocity over here. So I'm just going to say A and B. Okay, so the velocity here at point B is a lot greater than the velocity here. So this line at the bottom has to be a little bit longer than the line on top, just to represent a greater velocity. I hope that makes sense. Okay, so okay, I did go back to the graph. No, remember in free fall, the only force acting on an object is gravity. A hot air balloon going up at a constant velocity will have gravity, and it will have this applied force, right? The force of your balloon or of the hot air pushing it up. If it's traveling at a constant velocity, it means that the net force is zero. But in order to be in free fall, only gravity needs to be acting on you. So you only need to see something like this. All right. Then you are in free fall. Okay. So like I said, you get marks for the shape of the graph. You also get marks for indicating the correct times on the graphs. Okay. Yes, so before the fuel ran out, guys, the rocket was not in free fall. If there is another force busy pushing you up, you are not in free fall. Only when the force of gravity is acting on you, then you are in free fall. So if there's only gravity, like you see in this picture here, you are in free fall. If there's any other forces, you are not in free fall. I hope that answered our question, guys. So a projectile is an object in free fall, okay? So it moves under the influence of gravity. Okay. But I think the definition is in your exam guidelines. So just give it a look. Alrighty. I think we are making good time. Yes, we are. Okay. Question 4 states a pendulum with a bob of a mass of 3 kilograms is kept stationary at a height of 1.2 meters above the surface. It is released, and at its lowest point, it collides with a block, mass 1 kilogram, which is at rest on a frictionless surface as shown in the diagram below. Ignore the effects of friction, and it says the diagrams are not drawn to scale. Oops, sorry about that. 4.1 states, state the principle of conservation of mechanical energy in words. Guys, there's your definition, a very easy 2 marks, okay? Let's move on. Now it states, using energy principles only, calculate the speed of the pendulum bob just before it hit the block. So I want to know, how fast was it traveling just before it struck the block? And we have to use energy principles, nothing else. If you used another equation, even if you got the correct answer, you would not get marks because you are not following your instructions. Now here's a clue that they've given you. The question before says, state the principle or the principle of conservation of mechanical energy. So for this question, I'm just going to use mechanical energy. I'm going to say that the mechanical energy, E mech on top, is equal to the mechanical energy, E mech, at the bottom. All right, so this is just U at the top, which is our potential energy, plus my kinetic energy at the top is equal to U at the bottom, plus the kinetic energy at the bottom. Now, guys, usually kids this step, they expand their stuff, they substitute. I personally like to first rearrange equations first before I substitute. Number one, it just makes it an easier thing to type onto my calculator. But number two, and most importantly, it prevents me from making any errors during my rounding off. So let's think about it. right at the top, they said it was kept stationary. So right over here, I know my initial velocity is 0. So my kinetic energy at the top is going to be 0. Right here at its lowest point, its height is going to be 0. Okay, so it's going to be no potential energy at the 0. Oh, sorry, at the bottom. So therefore, my potential energy on top is simply equal to my kinetic energy at the bottom. So remember, potential energy is mgh is equal to a half m times v squared. And I want to know what is the value of v. Again, I can still simplify this. So I can cancel out my masses because it's m times something on one side, m times another thing on the other side. And when you have something like that, you cancel it out, right? And then I can take the two other sides. I get that my v squared is equal to 2g times h. So therefore, v is simply the square root of 2 times g times h. You now type it all onto your calculator. It's the square root of 2 times 1.2 times the mass, times the 9.8, which is the gravitational constant. And therefore, the velocity just before it hits my block is, let me see, 4.85 meters per second. 4.85 meters per second. And there we go. Very, very simple. And you see, the stuff I had to type on my calculator was a very simple calculation. All right. Sometimes it's better to do that than to just write equations, write down the answer. Then you have to use the calculator. It just child's time. First, rearrange all your formula using basic algebra, and then you can substitute. Okay. So let's move. It says now, let's do it over here. After the collision, the pendulum bob has a velocity of 1.8 meters per second, and the block moves up a frictionless curved ramp until it reaches a maximum height, h, as shown below. Assume that no loss of mechanical energy occurs during the collision. Okay, so no energy is lost. So I know that this is what type of collision is this? If no energy is lost. What type of collision is this? Yes, sir, the mass is 3. So if no energy is lost during a collision, what do we call that collision? Very good. It is an elastic collision. All right. If energy is lost, it is an inelastic collision. All right. So 4.3 state the principle of the conservation of linear momentum. Again, it's a definition question. I'm not going to get too much into that. 4.4 states calculate the magnitude of the velocity of the block just after the collision. So guys, what did you get for that answer? Who can tell me what their answers were? Yes, the slope can have friction in other questions. You must just, it depends on the question, but yes. But I don't think they will give you a curved slope with friction. That's not at this level. I get 8.4, 9.15. What did I get? Okay. So let's figure it out. Again, look what they asked us, the conservation of linear momentum, conservation. So I know I need to use this equation. The sum of my initial momentum before the collision is equal to the sum of the momentum after the collision. So that simply becomes the mass of A. A is just going to be my pendulum bob. B is going to be my block. This becomes the mass of A times the initial velocity of A plus the mass of B, which is my pendulum, times the initial velocity of B, is equal to the mass of A times the final velocity of A plus the mass of B times the final velocity of B. Again, let's look over here. What was my initial velocity for my block? It was 0. So I know I can cross this out, okay? And I need to figure out what is the final velocity of B. So what I'm going to do is I'm going to take this to that side, and I'm going to get that the mass of A, VI, minus the mass of object A times the final velocity of A, all right, all of that divided by the mass of object B, that is equal to my final velocity of B. So let's just understand how I got it. I first took this thing that side, and I divided both sides by the mass of object B. It's just simple algebra, all right? And now I'm going to substitute into my equation. So this becomes, what is the mass? This was 3 kilograms. So this becomes 3 times, what is my initial velocity? 4.85 minus 3 times 1.8 over, what is the mass of object B? It's 1. All right, and therefore, the final velocity of B, if you type this all onto your calculator, you get a 9.15 meters per second. Done. Now, do I put in direction? All right, let's see what the question is saying. It's saying calculate the magnitude. They just want the size. They do not want the direction. They just want to know what is the size of my velocity, irrespective of its direction. Okay? So there we go. On top of that, guys, I did forget to put this in, but you must always take a direction to be positive. Luckily, in this case, everything was moving in the same direction. But in other cases, you might have them moving in opposite directions. So you have to take a direction to be positive. Okay? Do we all understand that one? A pretty simple one. And then finally, 4.5 says, calculate the vertical height reached by the block, right? So what was the answer for the vertical height reached by the block? Who can tell me? Very, very, very good, Hope. Okay, 4.27. What else did anyone other guess? Okay, perfect. You see, guys, everyone is getting very good answers here for physics, right? So I assume we are all going to get an 80%, hopefully. 80% and above for physics paper 1, because you guys can see it's very simple. You just have to practice and you're going to get an easy 80%. Okay, guys? Well done. So, again, what can I do? Well, I know that at the maximum height, so at the maximum height, my final velocity is always 0, okay? Because I can't go any further than that. So at the maximum height, my velocity is 0, okay? So again, I'm going to use my mechanical energy equation. So I'm going to say that, oops, the potential energy, because I'm first starting here at the bottom, and then I'm moving my way to the top. So I'm going to say that the potential energy at the bottom plus the kinetic energy at the bottom is equal to the potential energy at the top plus my kinetic energy at the top. Again, look here, my kinetic energy is 0 right at the top here because my velocity is 0. My potential energy at the bottom is 0 because we're starting at height 0. So therefore, the kinetic energy at the bottom must be equal to the potential energy on top. That's 1 over 2 m times velocity squared is equal to m times g times h. Now look over here. This cancels with that. The m's cancel. If you divide both sides by g, you therefore get that h is equal to v squared divided by 2 times g. You then substitute, all right? So this v squared was the velocity of my block at this point over here, right? We calculated that in the previous question. It's 9.15 squared over 2 times the 9,8. And therefore, my maximum height reached was 4.27 meters. And Bob is your uncle. Okay, yes, man. Thank you, Nikal. And there we go. Bob's your uncle. Very, very easy question, right? Easy 3 marks on a platter. Moving on. I've got to animate my definitions now. Okay. Question 5 states, an 850 kg roller coaster is released from rest at point A on a track shown in the figure below. It travels along a straight line, a straight decline section, A to B, and continues to move along the curved section B to C, where the brakes are then applied from point C. Okay, so it moves from this point until here. Over here, we hit the brakes. All right, so this is when the brakes are hit. Okay. The roller coaster then comes to a stop at D, 50 meters from C. All right. The coefficient of kinetic friction of the track is this amount over here. Ignore the effects or ignore the rotational effects of the roller coaster's wheels. Guys, that's for those types of questions where you have to include rotational friction and all of that, that's waiting for you next year when you take physics in undergrad. Okay. 5.1 says, state the work energy theorem. That's your theorem. I'm not going to go into too much detail. Okay. 5.2 asks, draw a free label, basically draw a free body diagram showing all the forces acting on our roller coaster. And look how many marks it is. It is 3 marks, meaning I have to find 3 answers, or sorry, 3 forces. So you start off with a diagram or a little dot, and your first thing is you draw your weight. Bam. Weight is always straight down. Now there's going to be a frictional force because they've told us there's some form of friction, and our normal is going to be perpendicular to the surface. There, 3 forces for 3 marks. Done. Don't draw your components, okay? Maybe you can do it on a separate piece of paper, but don't include it in your answer, because if you drew your components, if I drew my components of weight instead of my actual weight, they would not mark it correct. Okay. Am I correct? Yeah. Let's just see. I can't really see that section. Yeah. 5.3 states, calculate the net work done on the roller coaster as it moves from A to B. So guys, what was your answer for that one? Please state it in the chat. So I get some water quickly. Okay, I see 227,000. Anyone else get any other answers? Someone said 819,000, 605,000. Wow. Okay, so there's a bit varied the answers. So let's go through it. Remember, the network done, as stated by the definition, you don't know how you got to the answer. That's never good. But okay, let's figure it out. Let's all figure it out. Okay, I see a lot of varied answers. So the network done is equal to your change in kinetic energy. Now, this is what I've always done, and it always works for me. I see that therefore it means that the net forces times delta x times the cosine of theta is equal to a half m times the final velocity squared minus my initial velocity squared. Don't forget the squares, guys. Please, if you forget that, oh, it messes up your whole question. All right. So when answering this, remember, you need to consider the net forces acting on the object. So you need to look at your force diagram, right? Now what I'm going to do is I'm just going to change the color. I'm going to include my components of weight. So remember, there's going to be my W parallel and my W perpendicular. Okay. You don't actually draw it on your actual answer. Maybe do it on a separate piece of paper, but those are the forces. And I'm going to look at the forces going up and down the slope. Oops. And I'm taking down the slope as positive. Okay. So what does it mean? I'm going to change my color back. It means that all the forces going down the slope is going to be a positive. All the forces up the slope is a negative. So what are the forces down the slope? It's W parallel. Remember, W parallel is mg times the sine of theta. Oops. So this becomes mg sine of theta minus my frictional force, which is that, all right, which is that times the normal, right? And remember, in this case, frictional force is equal to your coefficient times your perpendicular component, which is that times mg cos of theta. I hope you guys understand that. So it's simply my parallel component minus my friction. All right. And then now I've just expanded everything. And I get that this is mg times the cosine of, whoa. You see, now I'm going to confuse myself if I keep using theta. Okay. Because I have now 2 different thetas here. I'm going to say that this angle of inclination, I'm going to call alpha. All right. And you're going to see why now. Times alpha times delta x times the cos of theta is equal to 1 over 2 m. Remember, your initial velocity is 0. So this is just vf squared. All right? If I'm not mistaken, yes. Oops. But now here's an issue. I don't even have to consider my kinetic energy at this point. I can just say that this is my network done. All right, my network done. I don't even really have to worry about the kinetic energy in this moment in time because I actually don't know the velocity of the clot when it's here, okay? However, I can still figure out what the network is just by using this equation over here, okay, guys? I hope I didn't confuse you too much. I just used this equation for network, okay? And remember, the net forces acting on my object is this, my parallel component, minus my friction, right? So forces acting up and down the slope. Okay, hopefully you guys understand that. So therefore, the network done is equal to, this becomes 9,8, all right, times the mass of my thing, which is 850 kilograms, times the sine of 30, all right, minus the coefficient of friction, which was 0.42, oops, multiplied by 850 times 9,8 times the cosine of 30. All right. Now, what's my displacement here? Remember, for this, from point A to point B, it's 200 meters. 200 meters times the cos of what angle? Remember, this angle over here is the angle between your net force and your direction of motion. That's why I changed this angle over here to alpha. Guys, it is not the angle of inclination. Please understand that. This theta over here is the angle between your net force and the direction of motion. And you can see that both the net force is going down as well as the direction of motion. So I know that the angle between them is 0. All right. And now all I need to do is I type this on my calculator and I get that the network done is equal to 227,024.7045 joules. And there we go. Okay, so who understood what I did here? You can send a thumbs up, a thumbs down. Who would like for me to repeat this thing? All right, if you would like me to repeat, just state so in the chat. I think I might have just confused you a little bit. I do apologize. Okay. Okay, no problem. So I'm just going to repeat quickly. So whoever got this answer, congratulations, but I'm going to show you. So at the back of my formula sheet, I know that the network done is simply, oh, sorry. You know that the work done is your force times your displacement times cos of theta. So that means that the net work done is simply equal to the net force times your displacement times cos of theta. All right? Hopefully we understand that part. This is something that is given to us at the back of our formula sheets. So I'm just going to draw a little force diagram over here. It was friction, our weight, and the normal. Okay, the normal. What I'm going to do is I'm going to take my weight and I'm going to render it into its components. I'm going to just change the color. So remember, weight can have its perpendicular component to the inclined surface and the component that is parallel, my W parallel. Hopefully we understand that one. Now what I'm going to do is I'm going to take down the slope as positive. So all the forces going down the slope is positive. All the forces going up the slope is negative. So therefore, the network done is equal to, now what's the net force? It is simply my parallel component minus friction times my displacement times cos of theta. All right? Remember, for your parallel component, it's mg sine of theta. All right, remember friction, as I showed you over here, is equal to your coefficient times your normal. But in this case, my normal is the same as my perpendicular component, as I've shown you over here. All right, so therefore my friction is simply the coefficient times mg times cos of theta, delta x times cos of theta. Now, again, I've made this silly mistake. I'm going to just change this theta into alpha. All right. Now, why am I changing it into alpha? Remember, alpha is this angle over here, the angle of my inclined slope. All right. This is something completely different. Okay. And then I substitute. So this is equal to 850 times 9,8 times the sine of 30 degrees minus 0.42 times 850 times 9,8 times the cos of 30. All right, times my displacement. So that's the displacement from point A to point B, which is 200 kilograms times the cos of theta. Now, guys, this theta is the direction of the angle between your net force and the direction of motion. So remember, your cart is moving down the slope and your net force is also going down the slope. So therefore, this is 0. All right. If it was some sort where you had just friction and your cart was moving that way and it was being slowed down by friction, theta would be 180 degrees. Okay. Hopefully you guys understand that. And again, you type it all onto your calculator and you get 227,024.7045 joules. Hopefully that made a little bit more sense, guys. Did that make a bit more sense? If you still do not understand, please just watch the video, repeat it, and then try and answer this question again using the method I've shown you, okay? Do we all understand a thumbs up or a thumbs down? Okay, I just want to see any more questions. Perfect, 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 perfect. Okay, perfect. Let's move on. Okay, so it says now, along the curved section BC, the kinetic energy of the roller coaster decreases by 108,950 joules. The brakes are then applied at point C. Okay, so remember, guys, at this point over here, that's when we hit the brakes. Okay. Calculate the magnitude of the average braking force required by the braking system to bring the roller coaster to a stop at D. Use energy principles only. So, who managed to figure this one out? All right, I want to see people's answers. So, what was your answer for this one? It was quite a tricky one. I'm not even going to lie. Luciana, okay, very, very good. I see one answer for that, 1,137.11. Anyone else got any other answers? Another one? Another one? Oh, okay. Okay. So everyone seems to be getting the same answer. Someone said 22. Okay. You're very weak brake systems, but okay. Alrighty. So I see we all have gotten the same answer. And guys, that is the correct answer. So well done. That would have been an easy 7 marks on the question. Or sorry. Yeah, it would have been an easy 7 marks in your test. I know when I first attempted it, I got it wrong because I have a very bad habit of not reading properly. And that's one thing you guys must do, guys. Please read properly. Don't just skim over it. Read carefully. All right? Because if you don't read properly, you might misunderstand something and then you do the completely wrong calculations. All right. So, number one, what did they say? I'm going to change it to a different color. I'm getting bored of doing the same colors. Just keep it at red. It's fine. They said at this point over here, my kinetic energy decreases by 108,000 and something joules. All right. So, the first thing I want to do is, okay, the first thing I need to know is, what is the kinetic energy of my object when it reaches this point over here? So the kinetic energy of BC is simply the kinetic energy, that it had at this point over here minus that 108,950. So therefore, the kinetic energy of BC is simply 227,000 and 24, oops, 24, comma 7045 minus 108,950, and therefore the kinetic energy at BC is 118,074.7045 joules. All right, so that is the kinetic energy of our card just as it reached point C. Using that, I can figure out how fast was my card moving at point C, okay? So I know that the kinetic energy at point C is simply 1 over 2 times the mass of the card times the velocity squared at point C. So all you do is you figure it out. The kinetic energy at point C is this value over here. It's 118,074.7045 is equal to 1 over 2 times 850 times the velocity at c squared. Guys, you type this all onto your calculator and you figure it out, and you get that the velocity at point C, so how fast was the cart moving at point C, is what, 16.668 meters per second. Bam. All right. That is the speed of our cart just before the brakes hit. Now we have hit our brakes. Okay. So what's happening now is this is our cart and we have hit the brakes. And so we have to firstly creating a frictional force. On top of that, we are hitting the brakes. All right. So that's what's happening. Remember, the track does have friction, and now we've added some brakes to it as well. Again, what do I know? I know that the net work done is equal to the change in an object's kinetic energy. So that therefore means that the net forces acting on our object times the displacement times cos of theta is equal to 1 over 2 m times my final velocity squared minus my initial velocity squared. All right? Now here's the thing. I'm just going to simplify this. I know that my final velocity squared is simply 0. Remember, that final velocity is when the cart stops. So I can ignore this whole thing over here. Okay, so I'm just going to neaten this up. This just becomes negative a half times the velocity or my initial velocity squared. And what's my initial velocity? Guys, it's the velocity at point C. So this is just the velocity at point C squared. All right, just neatening it up a bit. Now, what is my net force? I'm going to take right as positive. What's my next net force? It is these two forces going in the opposite direction. Now, because they are going in the opposite direction, they are both negative. So therefore, negative times the force, negative force of the brakes minus friction, all right, times my displacement times cos of theta is equal to negative 1 over 2 m times the velocity of c squared, all right? Okay, hopefully we all understand that part, okay? Remember, I took right as positive. Both of my forces acting on the cart is going in that direction, so both of them are going to be negative, and that's why I have them like that over there. So again, what I'm going to do is I'm going to expand everything. So this becomes a negative force of B minus, now to find out the friction is simply U times mg, because remember now, if this is our cart, we are on a flat surface. All right, so the friction in this case is going to be equal to the normal, and the normal on a flat surface is simply your weight, which is mg, right? Hopefully we understand that. Times my displacement times cos of theta is equal to negative 1 over 2 mv of c squared. So now I'm going to substitute in everything. I get that negative fb minus 0.42 times 850 times 9,8 multiplied by your displacement. Remember, that's from point C to point D, which was 50 meters. So it's 50 multiplied by the cos of the angle. Now remember, guys, my cart is moving that way, but the net forces are in the opposite direction. So the angle between my net force and my direction of motion is 180 degrees. That's equal to 1 over 2 or negative a half times 850 times 16.668 squared. All right. Now, guys, I'm just going to neaten this up a bit. I'm going to divide both sides by this value over here. And I therefore get a negative force of B minus 3498.6 is equal to negative 236. Positive 236. 1.4889. And guys, all you need to do is you solve for this, and you therefore get that negative FB is equal to 1137.11 newtons. So therefore, FB, or the force of my brakes, is 1137.11 newtons to the left. Remember, I've taken right as positive, and this is force is acting in the opposite direction. And that is my final answer. Do we all understand that one? You might have to watch the video and replay it, but it's just the substitution part which might have seemed a bit confusing. But the rest, I hope you guys will understand. Okay? So guys, do you understand that question? Yes or no, or maybe? You can give a thumbs up or a thumbs down. Yes, always remember, if you are going that way, because what's happening is my cart is slowing down, right? When you slow down, it means that the forces acting in that direction, yeah, it means that you have a net force acting in that direction. So if you are slowing down, you have a net force acting in that direction. And remember, that cos of theta is the angle between my direction of motion and my net force. So this cart is slowing down, but is moving in that direction. So my net force is going there, but my direction of motion is still going there. So therefore, the angle between the two is 0. Oh, sorry. The angle between the two is 180. All right. Hopefully that makes sense. So guys, I see a few partially. What don't you guys understand? You guys can state that in the chat. I can't really help you if you say you don't understand. You must just explain what you don't understand, and then I can assist you. Okay? But for the rest of us, do we all understand? It was quite a tricky question, so you might have to, like I said, try and attempt this question again on your own to figure it out. I have to show you again. Oops, let me just figure it, get my eraser. Just rub this all out. Ah, man, I rubbed out the wrong stuff. So basically what I did was, remember, I figured out what was the velocity over here. Once I figured out the velocity at this point, I could then figure out what the brake force was on my object. And then I did this section over here. So let me just get out my highlighter. Remember, this is the equation that's given to me. And again, this is the force diagram I drew. There's a frictional force. On top of that, there is a braking force. And all of that acts in the opposite direction. This is my equation for the net force, right? Remember, your final velocity is 0. So the final kinetic energy is going to be 0. So that's why I did something like this, right? Because remember, it is first a half m Vf squared minus Vi squared. And this Vf is going to be 0. So it's just a half m times negative Vi squared. And your initial velocity was the velocity at point C. Okay, hopefully that made sense. Okay. Now remember, I took, oops, take a different color. There we go. Remember, I took, man, oopsie doopsie. I took right as positive. Okay, guys? Remember, if I take right as positive, all the forces acting to the left are going to be negative, and that's why I made them like that. Okay? I expanded my friction. All right, that's what friction is, because remember, we are on a flat surface. Okay. And then all I did then was I substituted everything into my equation, and then I solved from there. Okay. And that's what my final answer was. I got a negative answer first. And when you get a negative answer, it means that it's acting in the opposite direction. That's what I said over here. So do you guys understand now? Okay. Remember, your friction is your coefficient times your normal. On a flat surface, your normal is your weight force, which is m times g. Okay? Does that make sense, guys? Do you understand a little bit now? All right, guys, do we all understand? You can give a thumbs up or a thumbs down. Okay, perfect. I hope this is a little bit more clear now to you guys. All right? Now, guys, we are just going to take a 10-minute break. Okay? So don't worry, we're going to take a 10-minute break. You may stay in the chat or you may exit the chat and just use the same link to rejoin the chat. Okay? But we're going to take a 10-minute break. So the time now is 10 to 3. So we are going to start at 3 o'clock. Okay? So guys, please, we will be starting at 3. So you can take a 10-minute break, go to the bathroom or something, stand up and stretch. And I'll see you guys at 3 o'clock on the dot. Okay? So see you guys soon. All right, guys. So welcome back. Welcome back. Hopefully, we went to the bathrooms and all that stuff. So, guys, let's get straight into it. We just have an hour left, maybe a little bit more than that, and then I'll let you guys free. Okay. So, question 6 states: a trained diver records the frequency of ultrasound waves emitted by a dolphin. A dolphin, which is when the dolphin, which is swimming at a constant speed of 20 meters per second, approaches the stationary diver, the recorded frequency is 253.38 kilohertz. All right. The dolphin passes the what is it? Yeah, the dolphin passes the diver when swimming away from the diver. Right, the recorded frequency is that amount kilohertz. All right, 246.71 kilohertz. Okay. Yes, we will be able to finish the entire exam paper, even if it kills us. Anyways, 6.1 state the Doppler effect in words. I think I forgot to put in that definition, but I assume you all know the definition, guys. Remember, that is in our exam guidelines. Next question says, use the information given and calculate the speed of sound in sea water. So, guys, what was the answer that you guys got? Okay. I see one answer. Okay, so we all are getting about 1,500 meters per second. All right. Now, believe it or not, that is the speed of sound in water. Remember, the denser your medium, the faster sound can travel through it. All right. So sound travels its fastest through solids and its slowest through air. Okay. And it doesn't travel at all through space or through a vacuum. All right. So when I answer these questions, I always like to write down what I have been given. So number one, I know that the velocity of my source, which is the dolphin, is 20 meters per second. So that dolphin is swimming quite fast. I also know that the velocity of my observer is 0 meters per second because he's stationary. That's the diver. The frequency that I've observed was 253.38 kilohertz, and that is when the dolphin was moving towards me. Okay. Then the frequency observed was also 246.71 kilohertz. All right. And that was away. That was when the dolphin was swimming away from me. However, I need to figure out what the speed of sound is underwater. And on top of that, I also do not know what the frequency of the source is. So guys, look over here. I have two unknowns. What does it mean if you have two unknowns? Who can tell me in the chat? If you have two unknowns, what is that? What alarm bells must be ringing in your head? Okay, so can someone please tell me? When you have two values that you do not know, what does it mean? Very good, Pilar. It means simultaneous equations. All right. So I'm going to change my color to this nice dark one. Okay, so I'm going to say towards. All right, and I want to focus on the stuff here. So I know that the frequency of my observer, or sorry, the frequency observed is equal to the velocity plus or minus the velocity of sound plus or minus velocity of my observer divided by the velocity of sound plus or minus the velocity of my source multiplied by the frequency of my source. All right. Now, here's the thing. Towards, if you swim towards something or if you move towards something, it's plus on top, minus at the bottom. On top of that, I know that the velocity of my listener is 0. So this I can just change to this. All right, because the velocity of my listener is 0. So that top part is not going to change at all. All right. Now, here's the thing, guys. I understand that it says kilohertz, but let's look over here. This will be 253.35, let's just say kilohertz. So kilohertz is equal to the velocity of sound divided by the velocity of sound minus 20 meters per second multiplied by 246.71 kilohertz. All right. Now you guys can all see that it's 1,000 here and 1,000 over here, right? That's what kilo means. It's multiplying that value by 1,000. So guys, I can just actually almost ignore it in the sense that if I just divide both sides by 1,000, I will get that answer over here. All right. So that's what you can do. You just divide both sides by 1,000 and you get that 253.35 is equal to that. Right? Oops, 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 oops. Oh, I've made a mistake here. That's where I've made a mistake. So I'm just going to keep it at 250,000 kilohertz is equal to that times the frequency of my source, right? And what I want to do is I want to make this the subject of the formula. So therefore, the frequency of my source is equal to 253.35 kilohertz. I'm just keeping it as that. I don't want to multiply it by 1,000. It's just going to take up too much space. So I'm just going to keep it at that. Multiplied by, now remember, I take this denominator, that side. So this is V minus 20 divided by V. All right. And that is the first equation. All right. Now I'm going to look at the point where the dolphin, oops, moves. Why is my thing not working so nicely? Oops, sorry guys. I think there we go. I don't know why my thing is being so silly. Away. So this is the point where the dolphin moves away from my listener. So therefore, the frequency observed is equal to V plus or minus velocity of my listener divided by V plus or minus the velocity of my source, right? Times the frequency of my source. Remember, if you move away from something, it's minus on top, plus at the bottom. On top of that, my velocity of my listener is 0. So I can just keep it as this. All right? And remember, the velocity observed when the dolphin was moving away from us is 246.71 kilohertz, right, is equal to V over V plus 20. That's the speed of my dolphin multiplied by the frequency of my source. And now, guys, I'm going to get the frequency of my source on its own. So this becomes 246.71 kilohertz. All right. I'll show you why I'm writing it out like this now. Multiplied by V plus 20 over V. All right. And that is my second equation. Now what I can do, guys, is I can figure out the velocity. Okay. So all I need to do now is I'm going to change the color. I'm going to say that the frequency of my source in my first equation is equal to the frequency of the source in the second equation. Okay. So therefore, 246 kilohertz multiplied by the velocity of sound, plus 20 divided by the velocity of sound is equal to 253.38 kilohertz, all right, multiplied by the velocity of sound minus 20 all over V. Now, this is what I actually wanted to explain. That is 246.71. Okay, let's not forget about that. Remember, that kilohertz means it's 246.71 multiplied by 1,000, all right? The same can be said for the other side. So I'm just going to rewrite this a bit neater, okay? And you're going to see what I mean now. Okay, so this is 246.71 multiplied by 123, and the same can be said for this side, 253.38 multiplied by 1,000. Now let's look over here. Number one, I have 1,000 on each side of the equation, and it's 1,000 multiplied by something on one side, 1,000 multiplied by something on the other side. On top of that, I have both sides under the same denominator, all right? It's one side, all of it divided by V. The other side, all of it is divided by V. So therefore, I can cancel both of this out, all right? So all I'm left with at the end is this, all right? Oops. Yeah. It's basically 246.71 multiplied by this bracket is equal to 253.38 multiplied by that bracket. And all you do, guys, is you multiply everything out. Okay, so this becomes 246.71 V. What's this? Plus 4934.2 is equal to 246.7. On 253.71. Do apologize. This becomes 253.38 V minus 5067.6. All right. And now you take all the V's to one side and you get that 6.67 V is equal to 10,000 and 1.8. All right, and now you type that all onto your calculator and you get that therefore V is 1,499.52 meters per second. And that is your final answer. Do we all understand that one? All right, you just had to use simultaneous equations. Hopefully you wrote it a little bit neater than I wrote it over here. Ooh, let me just neaten this up quickly a bit. All right, it looks very untidy here. Okay. This just becomes 246.71 multiplied by V plus 20 is equal to 253.38 multiplied by V minus 20. Okay, that looks a lot better. All right. You solve for V and you get that speed. And that is how fast sound travels in water. Okay, or in seawater. 6.3 states, all right, guys, remember, if you are still struggling to understand, just try and look at the videos a bit later on tonight and replay it a bit. I think you will understand. Sometimes you just have to replay the video a bit slower and you will understand it a lot better, okay? 6.3 states, if the dolphin's constant speed increases to 25 meters per second, how will the frequency of the ultrasound waves emitted by the dolphin compared to the waves emitted when the dolphin was swimming at 20 meters per second? Write down higher, lower than, or higher, lower, or remains the same, and give a reason for your answer. So guys, state in the chat, and please state a reason. Okay, I see a lot of higher than, lower than. I see it remains the same. Anyone else want to answer that question? Now, here's the thing, guys, and I want you to think of it intuitively. Let's say you can even try it at home. Ask your dad or your mom to take you out on the road, and then you can try it. If I'm in a car and I'm driving towards you, so let's pretend this is a car, or right, this is an ambulance. Okay, this is an ambulance, and the siren is going off, and then this is an observer. All right, and that ambulance is going off, and he's approaching the observer. All right. And now in the ambulance, the person now is starting to die, and the nurse is like, okay, guys, we need to rush to hospital. So the ambulance presses on the accelerator. I think we can all agree that this person is going to hear some sort of a change in the pitch of sound, right? It's going to make that meow, that effect, all right? But how is it going to change for you in the ambulance, right? You are basically moving at the same speed as the source. Now think about it. If I'm in an ambulance and I press on that accelerator to speed up, am I going to hear anything different? No. All right. The frequency that I emit is going to stay the same. It's just going to change for an observer standing a little bit further away. All right. But for the object itself, or for the person who is emitting the frequency, nothing is going to happen. All right. So it remains the same. The same. And your reason can say that the frequency of the source is independent of its velocity. Does that make sense, guys? Remember, all right, the frequency of your source does not depend on its velocity. All right, so that dolphin can be moving at the speed of sound if it wants to. The frequency of its waves that it's going to emit is still going to be that frequency, right? It's not going to change. What's going to change is the frequency that you observe as a person. So yes, if that dolphin sped up, what you would have heard might have changed, but from the dolphin's perspective, it's still emitting that same frequency, all right? I hope that makes sense to us. So well done for us who got it right and who said remains the same and also provided a reason. Okay. Moving on. Question 7 states, the diagram below shows two small identical metal spheres, R and S, each placed on a wooden stand in a vacuum. Spheres R and S carry charges of as positive 4 microcoulombs and positive 2 microcoulombs respectively. Spheres R and S are brought into contact for a while and then separated by a distance of 8 millimeters between their centers. All right, so that's the distance after so you basically bring them, they touch, and you move them apart. 7.1 asks, which sphere loses its electrons? So guys, what was your answer to that question? Okay, now think about it. All right, which one has the most protons, right? Sphere R, okay? It's the most positively charged, so it's going to have the most electrons. So when they are brought into contact, this sphere is going to give off some of its electrons because it wants that high positive charge to be brought down, all right? So it wants to gain a bit more charge. Sphere S wants to gain a little bit more charge, and sphere R needs to lose a little bit more charge in order to be equal. So that therefore means that sphere S will loses electrons or loses the most electrons, all right? Because it wants to bring that other charge R, which is a lot higher, a bit down. Okay, so it's going to give some of its electrons to sphere R. Sphere R is going to become a little bit more negative, bringing that positive charge down a little bit more. All right, draw the electric field patterns. So remember, you start off with two dots, all right? And this is for R, and this is for S. And what I'm going to do is I'm going to draw something like this. Joops. You draw lines going out, and where they interact, you draw these curved lines like this, okay? Something like that. And then I'm going to do it the same for S, something like that. And then again, 1, 2, 3. Now, can you guys state for me, are the electric fields going to move out, away from the dot, or towards? You guys can answer that for me in the chat. Is it moving away or towards? Good, it is moving out or towards. So the charges will look something like that. Okay, please guys, do not get that mistaken. Like that. And remember, because they are both positive, the electric fields do not interact. They're almost like, they bump against each other and they do what you see over here. And again, a very, very easy 3 marks. Okay, moving on. Calculate the new charge on sphere, let's say, I'm going to read over here, on sphere R calculate the new charge on sphere S after contact with sphere R. So remember, guys, you use this formula. Now take note of this formula. It's not present on your formula sheet. So Q new is equal to the charge of QS plus the charge of QR over 2. Now, here's the thing. With this, when you calculate your new charge, you don't have to convert it into coulombs, and you can include whether it's a positive or a negative charge. All right, so that becomes 6 plus 2 over 2, and your answer is 4 microcoulombs. All right, so therefore the new charge on each sphere is positive 4 microcoulombs. All right, very, very good. All righty. Now, it says calculate the number of electrons transferred during contact. So, the number of electrons, the number of electrons is equal to your charge divided by the charge of an electron. But guys, what's happening over here? We are changing our charges, all right? This is during the time that they are in contact. So we are going to have a change in charge there divided by the charge of the electron. So therefore, my number of electrons is our final, which is our new charge, minus our initial charge divided by the charge of an electron. You could have done it for any sphere, sphere R or sphere S. What I'm going to do is I'm going to stick to sphere S because the previous question asked for sphere S. So I'm going to use sphere S. Okay. So what's the new charge? Well, for both, it's all 4 micro thingies. What's it? Microcoulombs, right? Minus, now remember, for this one, I consider only the magnitudes. I'm not worried whether it's positive or negative. That was just for the new charge. Right now, I'm just looking at the magnitude minus the initial charge of sphere S, which was 2 microcoulombs, divided by the charge of an electron, which is 1.6 times 10 to the power of negative 19. Now, here's the thing. I can't just write 4 minus 2 over 1.6 times 10 to the power of negative 19. I need to convert both of those microcoulombs into coulombs, all right? The only place where you don't have to convert it was for the previous question for the new charge. Any other place, you have to first convert it. So, 4 microcoulombs, or let's just write it like this. 4 microcoulombs minus 2 microcoulombs, that's just 2 microcoulombs. So 2 microcoulombs, how many is that in coulombs? So how much is 2 microcoulombs in coulombs? You guys can just write it down in the chat. So what must I do to convert 2 microcoulombs to coulombs? Okay, I see power of negative 3. Okay. Remember, guys, always remember this. Munip, M-U-N-P, and I go 3, 6, 9. So munip or manup, 3, 6, 9, 12. And I want to know what is the value for this, is this one over here. So this becomes 2 times 10 to the power of negative 6, all right, because that's for micro, divided by 1.6 times 10 to the power of negative 19. All right, so therefore the number of electrons becomes 1.25 times 10 to the power of 13 electrons. All right, so the only thing you had to know is during that time that they were in contact, there was a change in charge. All right, so therefore the number of electrons exchanged would be that change in charge divided by the charge of an electron, and that is your answer. So there was about 1.25 times 10 to the power of 13 electrons exchanged between those two spheres. All right, moving on. 7.5 says point X is located 2 millimeters to the right of sphere S as shown below. Okay, 7.5.1 says define the term electric field at a point in words. That's just your definition, guys. I'm not going to go into too much detail. It is present in your exam guidelines, and please make sure you guys understand it almost out of the top of your head. All right. 2.5.2 states, calculate the net electric field strength at point X due to the spheres R and S after R and S have touched and separated. So this is after they've gotten their new charge. And remember, just in case you forgot, this is 4 microcoulombs. This is also positive 4 microcoulombs. So guys, what was your answer for this one? Okay. Okay, perfect. You guys got it. So remember, number one, this point we assume to be a positive. All right. That's the first thing. Do I have space? Yeah. So this is our point X. All right. This is point X. Now, what's going to happen between point X and point S? Well, there's going to be an electric field going that way because they are both positive. So this is the electric field due to S. Now, what's going to happen between point X and point R? Again, they are both positive. So there's going to be an electric field, all right, due to point R. Okay, so why is it being so silly? I know that the electric field is K Q over R squared. So that therefore means that the electric field due to S is K times the charge of S divided by R squared. So that becomes 9 times 10 to the power of 9. The charge of S is 4 times 10 to the power of negative 6 divided by the distance. Now, what's the distance? It's 2 millimeters. But guys, remember the unit for distance or the displacement is always meters. So that becomes 2 millimeters divided by 1,000 squared because there's 1,000 millimeters in 1 meter. And therefore, the electric field due to S is, if you type it on your calculator, you get 9 times 10 to the power of 9 newtons per coulomb, right? Okay, that's the first one done. Now let's look at the electric field due to R. Again, that's K times the charge of R over R squared. So that becomes 9 times 10 to the power of 9. The charge of R is the same as the charge of S. That's 4 times 10 to the power of negative 6. Now what's the distance here? Well, it's that distance plus that distance. All right, hope that makes sense. Okay, so this is about 8 millimeters. That distance is about 2 millimeters. So that becomes 10 over 1,000 squared. All right, and therefore the electric field due to R is simply 3.6 times 10 to the power of 8 newtons per coulomb. Right. I'm not done yet. Okay, I need to now figure out the net electric field. So therefore, my net electric field is simply the sum of the electric field due to S plus the electric field due to R. Remember, you need to take a direction as positive. This is a vector. So I'm taking to the right as positive, meaning that if I look at my force diagram or my little diagram that I drew here, everything going to the right is positive. So I can just add these two. So this becomes 9 times 10 to the power of 9 plus 3.6 times 10 to the power of 8. And therefore, my net electric field is simply 9.36 times 10 to the power of 9 newtons per coulomb, right? And that is my final answer there, guys. I hope we all got it. All right. Well done. Everyone in the chat did get the correct answer. So it's about 9.36 times 10 to the power of 9 newtons per coulomb, right? Okay. Quite easy so far. Moving on. Question 8 states, grade 12 learners conduct an experiment to determine the internal resistance of a battery. They connect the battery to a rheostat, an ammeter, and a voltmeter as shown in the diagram below. So this is our little thing over here. And then the results are obtained in the graph below, and this is the graphs that we got. And we need to now interpret the graph and even that little diagram that they've given us to answer the question. All right? So 8.1 says use the graph, all right, to determine the value of the following. Number 1 states determine the EMF of the battery. So who can tell me what was the EMF? What was your answer for the EMF? Very, very good, guys. It's 12 volts. Remember, the voltage is equal to the EMF, or sorry, the voltmeter reading V is equal to the EMF when your current is 0. All right, if V is connected to the battery, okay? Always remember that. So if my voltmeter, is connected to the battery and there is no current going through the circuit, the reading on the voltmeter will match my EMF. All right, so I look for the point of the graph where the current is 0 and I have a reading for the voltage, and I get it over here. So therefore, my EMF is 12 volts, right? Pretty simple. 8.1.2 states, determine the lost voltage when the current is 2 amps. So what was your answer for that? Who can tell me? Very simple, 1 mark. Very good, guys. Very, very good. So you have to interpret the graph. So I'm going to look, where is my current to? Over here. And I want to figure out what is the voltage over here. So therefore, my potential difference or my external voltage is 8 volts. And we all know that EMF minus your external voltage is equal to your lost volts, also called your internal voltage. So therefore, my lost volts is equal to 4 volts. All right? Pretty simple. And finally, guys, determine the internal resistance of the battery without using this equation. So what was your answer for this, guys? Okay, 2 ohms. I see someone said 2 ohms and they got in that symbol. Very good. I don't know how you use that symbol, but good. So you can take any point and you can figure it out. I'm just going to take this point again. Okay, this was the point that we got in the previous question. And this is the point 8 and 2, right? This is for our voltage and that, oh, sorry. Yeah, this is for our voltage and that's for our current. Okay, so I know that the lost volts was 4 volts, all right? That's what I calculated in the previous scenario. And we know that our lost volts is our current times our internal resistance. So therefore, 4 is equal to our current. Now, what's our current? It's 2. 2 times R, and therefore our R is equal to 2 ohms. And guys, you could have used it anywhere, and you would have still gotten the same answer. All right? Remember, your internal resistance is a flaw built into the battery. It stays the same no matter what you do. All right? Hopefully that made sense. Okay. So moving on. Right? So if I use this point over here, I would have gotten the same answer, this point, that point, or this point. Okay, no, not these points. All right? Any other point, I could have used it. Moving on. So 8.2 states, in the circuit diagram below, the battery has an EMF of that amount and an internal resistance of 0.5 ohms. The voltmeter V is connected across the battery, ammeters A1 and A2, and the connecting wires have negligible resistance. So we can ignore that, all right? So this is our circuit diagram over here, all right? This is our EMF, this is our internal resistance, and this is the voltmeter connected to our battery. So define the EMF in words. I'm not going to get into that, guys. We understand that. What is the reading on voltmeter V when the switch is open? So guys, what is the reading of our voltmeter when the switch is open? Remember, it is always your EMF. So V is equal to our EMF, which is 19.125 volts. Now it says switch S is now closed. All right. The reading of on our voltmeter V decreases by 6.5 volts. Calculate 8.2.3 states the current flowing through the battery. All right. So how did we figure this out? All right. There was a few ways. So what was the current? I see one person got 13 amps. Is he correct? Is he incorrect? Are they incorrect? Okay. Remember, that 6.5 volts is equal to our lost volts. All right. So V lost is I times little r. So that means that 6.5 is equal to I times 0.5. So therefore, I is equal to 13 amps. There we go. Easy 3 marks on a plate. Moving on. All right. 8.2.4 states, calculate the reading on ammeter A1. So what did we get for A1? Who can tell me their answer? I see one answer. I see one answer. Okay, 1.08, 1.08. Anyone else got any other different answers? Okay, so let's see it quickly. I got 2. Okay. So remember, one of the most important things you need to ask yourself is, what am I dealing with? I'm dealing with a parallel circuit. All right, so So there are 2 things that happen. Number 1, the voltage in each branch is the same. All right, the current divides. Okay, that's very important, guys. That's what you need to know about parallel resistors. All right, for series resistors, the current in each resistor is the same and the voltage divides depending on your resistance. All right, that's what you really need to understand. So what I'm going to call this side branch 1 and this side branch 2. Now, what do I know? I know that the voltage in each branch is the same, or the external voltage is the same. All right. So I want to find out the reading on A1. So I'm just going to consider branch 1. So I'm just going to write here branch 1 because I'm considering it. Right? That's what I'm going to use to answer my questions. So the voltage for branch 1 is equal to 12.6 to 5 volts. All right. Yeah, that's the voltage going in that branch over there, right? Remember, my my voltage decreased by 6.5 volts. So that is now the voltage that is going through branch 1, all right? And that's going to be the same voltage going through branch 2, okay? So therefore, the voltage in branch 1 is simply the current going through that branch multiplied by the resistance, right? Now I know what the voltage through branch 1 is. I need to figure out the current, but what is the resistance? So what I'm going to do is I'm going to calculate it over here. The resistance of this whole branch, all right, my resistance is simply that resistor in series, which is my 10 ohms, plus that those 2 resistors in parallel, which is the 5 and the 2.5. So that it just becomes 10 plus. Now I need to figure out this. A quick way you can do it is your product over sum. So that's 2.5 multiplied by 5 over the sum, which is 7.5. All right, and therefore, if you type this out, you get that this value is 35 over 3 ohms. I'm not going to put it in decimals. I'm going to keep it like that and only round off at the end. So therefore, that means that 12.625 is equal to my current times 35 over 3 ohms. All right, you type everything out onto your calculator and you get that your current is equal to 1.08 amps. So therefore, the reading on A1 is 1.08 amps. And there we go. Bob's your uncle. That is your answer. Quick, easy 4 marks on a plate. You just had to figure out the resistance. All right. I'm not a fan of this product over sum equation, but just for now, I used it because it's a quick way to get the answer out. All right. Do we all understand? You can give a thumbs up, a thumbs down. We are almost done. We just have 2 more questions to go. Your electrodynamics as well as your photoelectric effect. But we all understand a thumbs up, thumbs down? Perfect. We are making good time over here. Now it says switch S is now closed. Sorry, that's the same thing. It says now calculate the unknown value of resistor R. So we need to figure out this one. So what is your answer for resistor R? What did you guys get? What you guys can post it. So what was the resistance of R? Post it in the chat if you want to. Okay. Okay. Good, good, good. Okay, so let's figure it out. Now, what do I know? I first know that the total current is equal to 13 amps. I also know that in parallel circuits, the current divides, all right? And remember, current is like water. It always goes through the branch. Most of it will go through the branch that has the least resistance. So out of all the current, 1.08 amps went through this branch, and the remainder went through this branch 2 over here. So therefore, the current for branch 2 is simply equal to 13 amps minus 1.08, and therefore the current for branch 2 was 11.917 amps. So now I know the current. Remember, the one thing that stayed the same was the voltage across each branch. All right, so therefore, the voltage of branch 2 is simply the current of branch 2 multiplied by the resistance. All right, and there's only one resistor here, so I can keep it as the resistance. So therefore, the resistance is simply the voltage over the current for branch 2, which is 12.625 over 11.917, and you get 1.06 ohms. And there we go. Easy 3 marks and Bob's your uncle. Simple, easy questions. All right. Circuits is usually the place where you have to get the marks. All right. This is almost like your redemption section after mechanics kicked your butt. Now, the final one states, an unknown resistor R is now replaced by a conducting wire of negligible resistance. So guys, I've removed R and I've placed it with a normal wire. So I've put just a single wire there. How will the reading of the voltmeter be affected? Write down increase, decrease, or remains the same. So what was your answer for that one? And please, guys, provide a reason. You can't just write one answer. You must actually provide a reason why. So yes, it decreases. So why does it decrease? Who can explain? Okay. So remember, what have I created over here? I've created a pathway with zero resistance. So what's my current going to do? All of that current is going to go through this pathway over there. So I've created what you call a short circuit. So this is what essentially a short circuit is, okay? You've created like a detour for the current, okay? So what happens is my total external resistance, because now this whole branch technically falls away now. All right, this whole branch falls away and all the current is going through here. So my total external resistance decreases. All right, I hope we understand that. When your total resistance decreases, my current increases. Now, I know that current and voltage are directly proportional, but you need to consider one other thing, and that's your internal resistance. The more current you get, the more lost volts or the more energy is lost as the current passes through the battery. So if current increases, your lost volts increases. So therefore, remember your external resistance is the remaining energy that goes to the battery. So if more energy is lost, the remaining energy for your circuit, is a lot less. So therefore, your external voltage decreases. So therefore, the answer is decrease, right? And there we go. Easy 4 marks on the plate. 1 mark for your answer, and then 3 marks for your explanation. Okay? We go. Guys, 2 more questions left, but are we all right? Are we surviving? Yes or no? Are you guys still awake? Okay, any questions you would like to ask me? We have 15 minutes left, and I think we can make some good time. Okay, perfect, perfect. Almost done, guys. Just hang in there. So question 9 states, a diagram of a simple generator below. Oh, sorry, study the diagram of a simple generator below and answer the questions that follow. So 9.1, we can all answer this. Is this a DC or AC? And give a reason for the answer. All right. So guys, what is your answer for this question? There we go. This is a AC generator. And why? Because of slip rings are present. Present. All right. Very simple. 9.2 state the energy conversion that takes place. So guys, what is the energy conversion? You can all state it. Let's see who can understand. Who understand? There we go. Mechanical energy. So mechanical to electrical energy. And finally, 9.3 states in which direction does the induced current flow? From state only A to B or B to A. So what does it mean, guys? I firstly need to focus, is my highlighter, on this section over here. All right, that's where A and B are. So you only worry about this section. So what is the direction of the current? Remember, number one, your magnetic field always goes from north to south. Okay, that's the first thing. So you obviously have to use your right hand rule. So number one, you point to the direction in which the magnetic field goes, which is from left to right. Then you ask yourself, is that section which we are focusing on, is it being turned upwards or downwards? And you can see this thing is moving clockwise. So that section for A and B is being moved upwards. So then you point your thumb upwards. Because remember, your thumb is your force, your pointer is your magnetic field, and your middle finger is your direction of the current. So look, it's going from left to right. It's being pushed upwards. And finally, you just stick your finger out to figure out where current goes. And it goes from A to B. So this one is from A, A to B. All right. Very good. Well done, guys. Okay. Almost done. You see, this is a very easy section. Yeah. What does it say? I just want to see. Yeah. So it states over here, it says the diagram below shows the EMF time graph for this thing over here. So 9.4 states, calculate the resistance of the load RL in the form, guys, you can see I've been teaching for long. Calculate the resistance of the load RL if the value of the IRMS is 4.55 amps and the maximum voltage is 150 volts. So what did we get for the resistance? All right, what did we get for RL? Who can tell me in the chat? You can just state the value. You don't have to put in the units. Right? Who can tell me what was the resistance for this? Oh yeah, you guys actually have to calculate it. Okay, we can calculate it together since we don't have time. So I know that R is equal to V over I. But now this is the thing. When you are dealing with AC generators or AC circuits, always remember it's not your voltage, it's not your current, it is your VRMS and your IRMS. All right? And I know what my IRMS is because they've told me that. I need to now figure out what my VRMS is. So VRMS is your maximum voltage over the square root of 2. So that becomes 150 over the square root of 2. Okay? Now I substitute it into this equation. So therefore R is 150 over the square root of 2 divided by 4.55 and therefore my resistance is 23.31 ohms. All right, that's the first thing. Good. All right, well done, well done. Now it says, yeah, load R is now replaced with a light bulb that has an energy consumption of, or power consumption of 400 watts. Assume that the light bulb is 100% effective and calculate the light energy emitted by the bulb in 3 minutes. All right. Now remember, power is simply, work over time, right? That's what power is. And when they say energy, they want to know the energy emitted. That means work, guys. Energy emitted, you need to think of work. So therefore, the work done is simply my power times my change in time. Now, what's the power? That's simply 400, because they've told me that. Now, my time. Remember, guys, time is measured in seconds, all right? So that becomes 400 times 3 times 60, all right? Because there's 67 in a minute, 60 seconds in a minute. That becomes 72,000 joules, all right? And that is the energy emitted in 3 minutes, okay? Hope we understand that one. All right, pretty simple. Now it says the speed of the rotation of the coil is now doubled, right? Redraw the above diagram in your answer book on the same set of axes. Redraw the diagram above in answer book, and on the same set of axes, indicate the old and the new pattern obtained. Label the new pattern B. So this is the original one. Right? Remember, this is time in seconds. This is my EMF in volts. All right. And what was the thing? It was 0.2 seconds. This is what 150. And then negative 150, and this is 0. All right? So what happens to your voltage when you double or when you increase the speed by 2? All right? What happens to your EMF? You guys can state it in the chat. Change the color. Good. Now, how do I figure that out? Remember, your EMF is negative N times your change in your magnetic flux divided by your change in time. This was something you covered in grade 11. Now, from this, I can see that my EMF is directly proportional to 1 over my time. Okay, so let's figure this out. Let's look at the time for one rotation, all right? So the EMF will still be proportional to 1 over the time for one rotation, which is that. Does that not look familiar? All right. I can say that therefore my EMF is proportional to my frequency. Now there's the thing. If you increase the speed, you increase your frequency. Because now instead of having one revolution every 0.2 seconds, you now have 2 revolutions. So your frequency doubles. So if my frequency doubles, my EMF doubles. If the speed doubles, my EMF doubles. This is just how you can derive it, okay? Just rub this all out. So what that means is my new graph is going to look something like this. It's going to go zoops like that. All right. Now, how long does it take for one revolution? It's just if your speed doubles, your time halves. So this will just be 0.1. And remember, my EMF is going to double. So this will be 300 and negative 300. This is graph B. And then graph A was the red one. Okay. And this is graph A and B. Do we all understand that one? That one is quite a simple one, right? Very easy marks. And you only had to draw it for one rotation, all right? Okay. Now it states, with what factor will the energy emitted, what factor will the energy emitted be if the speed of rotation of the coil is doubled, right? So basically, what will the factor of the energy emitted be, or with what factor will oh, it's been a long day. Sorry, guys. I also can't see the top part of our screen because there's something blocking it. Let me just see quickly. I'll just open the actual thing. There. With what factor will the energy emitted change if the speed of the rotation of the coil is doubled or 2 times faster? Explain your answer. So, guys, what would you say for this one? I'll give you 1 minute to try and answer that. Okay, starting now. Okay, so I see we might have misinterpreted the question. All right. So they're saying with what factor will this thing increase? It doesn't mean what much you do, it's what factor. So by what amount will the energy emitted change if the speed of the rotation is doubled? Right? So here's the thing. We know, oops, I'm just gonna write it like this. Your EMF is actually proportional to the speed of rotation. All right. So meaning if I double my speed, my EMF doubles, right? That's what we saw in the previous graph section. We want to know what factor will the energy emitted, all right? Your energy emitted is your work done, all right? That's a very important part, all right? The energy emitted is the work done. Now, we know, so therefore the voltage that your thing provides is also proportional to the speed of rotation, all right? So if speed doubles, the voltage or my EMF is also going to double. All right, I hope you understand that part, all right? That's what we figured out last. Now, I want to relate voltage and energy, which is work done. So I'm going to use this equation. Work is equal to V squared delta T over R. And I can see that my work done is proportional to my voltage squared. So what does that mean? If my voltage is doubled, my work is going to increase by a factor of 4, right? Because this just becomes 2 squared. So therefore, if voltage is doubled, work increases by a factor of 4. And there we go. Do we understand that now? All right. So if you double your speed, your voltage or your EMF doubles, and your work or the energy emitted is proportional to your voltage squared. So if your voltage is doubled, your work or your energy emitted increases by a factor of 4. Okay. Did that make sense? Okay. Anyways, guys, last question, and then we are done, almost done. Okay. One more big question. Let's over here in an experiment. An experiment is conducted to investigate the relationship between the wavelength of light incident on a metal and the maximum kinetic energy of the emitted electrons from the surface of the metal. The graphs below are not drawn to scale. Yeah, that's the results from the experiment. So 9.1 says define photoelectric effect. I'm not going to get into that, guys. We know what definitions are. 9.2 states, write down the value of the threshold wavelength for the metal used. So what is the value? You all correct. That's, remember, when when the work function is equal to the energy of your photon, your maximum kinetic energy is 0. All right? That's one thing. So basically, when the wavelength of our photon matched the threshold wavelength, right, my kinetic energy was 0. So therefore, this is 5.4 times 10 to the power of -7 meters. All right, that's actually for this section over here, right? So the threshold wavelength is 5,4 times 10 to the power of -7 meters. Bam. Okay. Calculate the maximum speed. What is it over here? Calculate the maximum speed of the ejected photoelectrons when the kinetic energy is x. All right, so we want to know what is the maximum speed of our electrons at that point. So guys, what did you get? Very, very good. For those of you who don't understand, remember, energy is equal to the work function plus your maximum kinetic energy. All right, so now that becomes hc over lambda. Remember, this is present in your formula sheet, if I'm not mistaken. Let's just see. No, let's just see. Yeah, hc over lambda is equal to hc over lambda 0 plus 1 over 2 times m times my v squared max. And I want to figure out what this value is. So remember, first, I'm going to rearrange my equation, all right? So I'm going to take everything this side. So this becomes 1 over 2 m times the v squared max is equal to hc over lambda minus hc over lambda sub naught. All right, so I'm going to factor out an hc, and I'm going to get 1 over lambda minus 1 over lambda 0. All right, and then what I'm going to do is I'm going to divide everything by 1 over 2m. So I want to get my v squared on its own. All right, so let's just take it over here. I know that v squared max, so this is my maximum velocity squared, is hc times 1 over lambda minus 1 over lambda 0, all of that over 1 over 2m. So I substitute, Planck's constant is 6.63 times 10 to the power of -34 times 3 times 10 to the power of 8, that's the speed of light, times 1 over this value over here, which is 3.2 times 10 to the power of -7, all right, minus 1 over the threshold frequency or the threshold wavelength, 5.4 times 10 to the power of -7. All of that divided by 1 over 2 times m. Now, what is m in this thing? M is the mass of your electron, which is at the back of your formula sheet, 9.11 times 10 to the power of -31. You type this all in and you get that your v squared max is equal to, I think it's 5.559 ... because it has a lot of decimals, times 10 to the power of 11. So therefore, Vmax, or my maximum velocity, is simply equal to 745,611.63 meters per second. And there we go. All right. So, guys, do you all understand this part? Very simple. All you just have to do is you rearrange the equation, you substitute, and you get your final answer. All right. Very easy, 5 marks on the plate. And then finally, your final answer is, let me just get out the question. How would the maximum kinetic energy of the photoelectrons be affected if the light of a higher intensity is used? Write down increases, decreases, or remain the same, and give a reason. So guys, for the final question, what was your answer? Yes, very good. It remains the same. Remains the. Now, why is that? Remember, intensity means number of photons. All right, so if you increase it in intensity, you only increase the number of photons. All right, increasing intensity doesn't affect energy of photons. So therefore, your maximum kinetic energy remains the same. There we go. And Bobby's your uncle. That's your final answer. Now, guys, that was paper 1 plus a nice little electrodynamic section. Do we all understand? Did we all manage to survive this? Do we all feel ready for paper 1 coming up on Friday? All right. Guys, again, I thank you so much for sticking in this lesson. All right. We really appreciate it. And good luck for paper 1. Okay. Remember, guys, just practice, practice, practice for the next 2 days. Go through as many past papers as you can, and just practice, practice, practice. I promise you, the more you practice, the more easy it becomes. But guys, from my side, from the Cape Town Science Center and from Astron Energy, we thank you for coming to our lessons, and we hope you enjoy the rest of the afternoon. And don't worry, we are going to make this recording available to you before 5 o'clock. All right, so you can study as much as you want. Guys, please feel free to like, subscribe, and comment on our videos. We would really appreciate your feedback, okay? But from my side and from our co-host, thank you so much for joining our lessons. Enjoy the rest of the afternoon and good luck for your exams, and especially paper 1. Thank you, guys. Bye-bye.